Warning! The video you're about to watch contains mathematics at the level of differential calculus, also known as Calc 1. All material has an assumed prerequisite of pre-calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. If you've been watching my video series on calculus here, this is our first kind of dipping of toes into derivatives. Now, if you notice, this is actually from a section in a textbook that's still in a limits section. However, I lumped this into derivatives because that's really what it is. In fact, it's titled that. So we're going to start this video series with just recalling what a tangent line is. Very short video here. Definition of a tangent line at F, or of F at A. Sorry, tangent line of F at A. Sorry about that. The tangent line to the curve y equals f of x at some point is a line through that point with slope defined to be the limit as x approaches A of f of x minus f of a all over x minus a. If you notice, by the way, that is the slope formula. You should notice that from your algebra classes, right? So that's y2 minus y1 over x sub 2 minus x sub 1. Some people also call this delta y over delta x, or change in y over change in x. It all means the same, but what we're doing here is we're taking the limit, by the way, that's an x sub 1 there. We're taking the limit as that denominator essentially goes to 0. So as, let's say, x2 approaches x1, or as delta x approaches 0, or as x approaches a. That's really what we're doing. We're allowing those points to get infinitesimally close to one another. Again, if you have watched the video series, I actually do a sample of something like this here. So we have an anchor point at x equals 0.8. Let's just say that's what we have right here. And what we want to do, so that anchor point, by the way, I'm going to call a comma f of a. And as you can see off to the far right, we have a point x comma f of x. All we want to do is drag that point that's far, far away at x comma f of x. We have to drag that closer and closer to a comma f of a, our anchor point. That's why we use the letter A for the anchor. And as you do that, you get very close to a tangent line at that point, a comma f of a, as long as you allow x to approach a. So limit as x approaches a is what you're dealing with here. And really what we're honestly dealing with is, in our definition of a tangent line here, is that we want the slope of this line to be f of x minus f of a all over x minus a as x approaches a. Now, if I get them right on top of each other, you won't have a line because you, if you think about f of x minus f of a, that's okay. Well, actually, that's not okay because that's 0. And x and a are the same point, so x minus a is also 0. So this fraction, so to find the slope, would be 0 over 0. So again, if these points are sitting on top of each other, you would have that numerator tending to, let me just point it this way, tending to 0, and the denominator's tending to 0, and that's a problem. It's called an indeterminate form. 0 over 0 is called indeterminate form. And so we don't want that. And that's why we often, or always in fact, in calculus, deal with limits. We want those points to get infinitesimally close to one another, but not actually touch one another, because if they do, you'll see, I can't seem to make it work, but there we go. You'll see that there's no such line because, again, it's an indeterminate form. All right, so that's a visual of what a tangent line looks like. And by the way, this line that I just happened to kind of open up there, yeah, it's a horizontal line. It doesn't have to be horizontal. There we go. But that would be called a secant line. It's a secant line all the way up to the moment when you have those 2 points grow infinitesimally closer to one another, and at that point you have a tangent line. So secant lines, there's quite some distance between the 2 points. Tangent lines, you're allowing those 2 points to limit to one another. Another thing that I want to mention here is that we have an alternative form for that slope called the difference quotient. It's the same exact form, to be honest with you. It's just that instead of x and a, you're dealing with the points. So up at the top, we were dealing with the 2 points, a comma f of a, and x comma f of x. That's how we found the slope. Difference in the two y values divided by the difference in the two x values. But another way you could have done this is you could have looked at a comma f of a, and a plus a little bit of a wiggle, comma f at a plus a little bit of a wiggle. Those are two completely different points. However, if you take the difference between the y values and the difference between the x values, you'd get, let's see, I'm just going to write it as slope here. You get the following. F of a plus h, I'll use that as my y sub 2, minus f of a, that's my y sub 1. Well, if f of a plus h is the y sub 2, then the x sub 2 is a plus h. And if f of a is y sub 1, then a itself is x sub 1. And when you just do a little bit of arithmetic, it becomes that. So this video is really just a really short introduction or reintroduction to the tangent line. It's going to be very important that you understand this. In the next video, we'll start into some examples.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.